Yeah,
recording, but it's not frozen on the screen.
You're good. Yeah, you're absolutely right. It's frozen for you guys because of the projector freezing it. It is not frozen. Yeah, I don't freeze the computer. I only freeze the projector. Very good analysis.
I learned that the hard way. I was waiting for you to freeze it because you were like covering your hand on a problem. When I was watching it at home, and you froze it and you moved your hand and the answer's right in front of you. Wow, that's great.
That's funny. All right. So here's the deal. Let's look at our cover sheet for the month. So here's our pacing right now. So here's the drawback and what we were talking about just now about how long the classes go. Last week we only covered 7-6 and 8-1, right? So today we're going to cover 8-2 and 8-3. Then next week we got to cover 4 sections. That sounds like a lot, but here's the deal with what I got so far on my website. If you guys paid close attention, I already have videos from last week, which is 7.6 and 8.1. So, Obad, you might be already familiar with all this. 8.1 and 2. So 8.1 and 2, the reason why there's overlap, why this one has 8.1, this was recorded with the advanced class, okay? So today, what I'm doing now is any class I record, I just put up the whole lecture on there. So you can go back and retake notes that maybe you didn't have time to copy down and stuff. And if you look closely, I already have notes for 8-3 and 8-4 for you guys. Again, that was recorded with the advanced class. And I haven't moved their videos yet, but on their month 7 and month 6 and 7, they went through some of that stuff already. So they already have a video for 8.5 and 8.6 and 2. So what I'm saying is there's videos for all the sections already up. So the thing is, it's like it's not at our pace. It might be at their pace, or like whatever students were there that day. It could be go faster, The good thing about coming to classes, we go according to how everyone's doing. But as a backup, we have all the lessons already up. So in case you want to go home, so let's just go back to the cover sheet here. Today we only get to 8.2 and 8.3. My heavy suggestion is to go watch maybe any order you want, these 4 sections. But next week, I'll tell you this. We get through these 2 today. Tomorrow or next week, we get through these 2. Probably won't touch these 2, but these will probably be videos you need to watch on your own, okay?
It'll be on the test.
Yeah, they'll all be on the test. All these sections will be on the test. So that's why I say look at the videos, because we don't cover it in class, but it's covered. So you see what I mean? So you kind of get all the access you need. But again, I always like to post up what we go through together, right? Just so like, oh yeah, that was the part in class I didn't get. You can rewind it and pause it. So that's kind of the beauty in these videos. So it's kind of cool. Regardless though, even though I have videos for 8.2 and 3, I still want to go through with you guys, right? So that's what we're going to do today. Okay, so let's go ahead and do that. Shoot. Okay, so let's do a warm-up really quick. You got like a part 1 for a warm-up. Here's your part 1. Huh? It will be the board, but here's your part 1 warm-up. So yeah, you could just go straight to the board now if you want. We got, because you don't have to copy the picture. So let's say that this is 1, 10. This is 5, let's say 2. I want you guys to find the midpoint for this line. Give me the coordinates for this midpoint. All right? That's going to be your part 1 warm-up. This is just a warm-up, okay? So Luke, let me grab you a huge personal whiteboard on this table. And you guys can all just work close together, right? So we'll grab this. All right, use those muscles you obviously got, all right? Strong young man over here, okay? Grab this space right here, right? Or you can use that whiteboard. We can bring it over here, however we want to. So this is our custom lesson. Right?
I don't think you did.
Does anybody remember what to do here?
Distance formula, right?
This is formulas to find the distance between these 2. However, midpoint formula, it's a little.
Isn't that the one term subtracting the other term divided by 2.
Oh, squared divided by 2?
No, so it's a... Yeah, it's not squared, but it's something divided by 2. So here, both these coordinates would be divided by 2, but what goes on the top here? Are we adding or subtracting this 2? I don't know.
No, adding, right?
You are, let's say, I'm going to freeze this for a second.
Think of that. Find the median. 2 numbers you add by 2.
I'm literally looking it up right now just because I totally forgot what it was. I think you add.
Yeah, because if you're trying to find like the middle number between like.
Obi's doing the right thing by just checking his cheat sheets. Very smart. I didn't think to do that. I did not think to do that. I'll put it up in just a second, but you guys want to save some time, Obi might already have it.
Fine.
Smart. If you can see it right there, it is x1 plus x2. The one's y2 or y1 plus y2. There you are. That's the formula right there. So please find the midpoint for those two, between those 2 points.
Yeah, that makes
We
sense.
can just pick which one is x1.
Yes, because this one, the order does not matter. If you add x2 first plus x1, it's the same thing as x1 plus x2. See what I'm saying?
Thank you.
All right, so what'd you guys get? 3, 6, 3, 6. Let's go over briefly how we did this. I'm going to write the answer in green, okay? What did you guys plug in for x1 and x2? 1 and 5. 1 plus 5 divided by 2 will be your x coordinate. 6 divided by 2 is 3. And your second point will be y2 and y1, which is 10 and 12. Those are the y coordinates. Oh, 10 and 2. Sorry about that. 10 plus 2 divided by 2. 10 plus 2 is
12.
Divided by 2. So the coordinates for this is technically 3, 6. It might be a review from Algebra 1. We're going to need the skill today, okay? Alrighty, so let's leave it at that. Here's your next one. Erased everything on the board right now.
Oh, we have one.
We got one more, okay? This is a warm-up, but it's a different type of warm-up, okay? It's just going to help you to...
None of that.
Who here remembers what a parallelogram is? Does anybody remember what a parallelogram is? What is it?
It's
Try to describe it, my friend.
it's like a rectangle, but it's kind of just tilted a little.
Tilted a little. Yeah. Let me draw one. Okay. It looks like a rectangle that's tilted. That's not a bad description. Okay. Let's get a little bit more technical now about what perfectly makes it. Yeah.
Both sides, or all opposite sides, are parallel and congruent.
Okay. And how about you?
Yeah, that's the
All right. So both pairs. This pair is parallel. What about these two lines?
Yeah.
They're parallel. By the way, what does that mean to say that they're parallel? What does that mean that they're parallel? They never intersect. That's the perfect way to say that. If these lines kept going straight forward, they never intersect. Also, what else is the same? Equal slopes. Perfect. The slopes are absolutely the same. And David, actually, very, very good job. You made another distinction that you had to draw 2 arrows here, maybe 1 arrow here, or it could have been the other way around. These two guys had to have 2 arrows, and these guys had 1 arrow to distinguish that their slopes, not all their slopes are the same, okay? Only these 2 guys have the same slope, making them parallel, and these 2 guys. Okay. So I would be very careful. Draw it like Obide in terms of how careful he is on his attention to detail. Because I'm going to ask you for a few things here, right? I'm going to do this in another colored pen. You probably can if you guys want to. You guys can do this in another colored pen. Draw diagonals from the vertices and the corners and connect them. Perfect straight ones. Not perfect, but try to get them as perfect as you can, right? All right, so theoretically, if we made perfect rectangles, let's try to figure out some things that we know about this parallelogram. What things do we notice so far that seem similar to each other? Like any sides being congruent, any angles, yeah?
They make two congruent triangles, two sets of congruent triangles.
They actually do. Yeah, that's true, but bigger picture, don't worry about the triangles they make. What does that tell you about the angles then?
The angles have to be the same.
Okay, so which angles do you see look the same to you? And I will tell you if you're right or wrong. Just take a guess here. Which angles look the same to you?
The ones that are opposite, the ones conjoined by the lines.
You're absolutely right. How about these angles?
Also the same.
Also the same. Check to see if your parallelogram looks roughly about the same across from each other. Nice. David, you said something about the lines. What else did I miss in here? I said that they're parallel, but what else is there?
Congruent.
Which ones are congruent to each other, Dave?
Opposite.
Yeah, so these two lines are congruent, and then these two lines are also congruent to each other. Check to see if your parallelogram is the same. That's why I said be very careful in that your parallelogram is carefully drawn. If you haven't noticed, your lines are exactly the same, the pairs. What else do I notice?
Center, I guess.
There's a center, yeah. Something about the diagonals. What is the diagonals? I don't know how to describe them. Like, what do they look like to you? Like, what relationships can we make out of the diagonals? You want to see? Okay, so don't worry. Huh?
They probably add to a certain length.
Right.
Determine.
They probably add to a certain length. We're going to come back to that one. But here's what I want you guys to do. Grab out your camera phones or something for the time being. You can make a cheat sheet with this. Okay, so you have to make the cheat sheet. This is going to help you on the exam. But for now, in class, why don't we take a picture of this? These are 4 different things that you want to know about. All right, you can just take it directly from my book here. 4 things you want to know about a parallelogram that we're going to use to our advantage. Some of these things we've already talked about, right? So David, look at what David said on, actually David's explanation that the sides are congruent. Which one of these theorems explains David's thinking? 8.3, 8.4, 5, or 6?
A phone.
A phone.
Right.
So carefully look over. So you can look down your phone. Huh?
8.3.
8.3 says, yep, opposite sides are congruent. So again, opposite sides are equal to each other. Okay. What about Zane's proposal that the opposite angles are congruent? 8.3, 4, 5, or 6? Which one explains that?
4.
4, that's right. Okay. So 4 here. Oh, yeah, 8.4. This one is a little tricky. This one looks exactly like it. You guys want to check this out here? Let's see. What if let me give you another example here on another piece of paper. Let's draw another pair. Let's do 8.5 really quick. 8.5 says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. What does supplementary mean?
360.
Okay, add up to
Or 180.
180, like a straight line, right? So let's use what we know so far. If this was 80 degrees, how many degrees does this have to be? Opposite. Huh? 80. They're the same thing, right? That means these two have to be the same as well, right? Do we know it yet? We don't know the angles though, do we? What do we say if we don't? What letter do we use if we don't know what the value is for? We just give it a value of x, right? So if this angle was x, what do you think this angle is going to be? Because it's the same thing, right? And let's go one step further, boys. All right. Sorry to nail it, that people. Right. Still got to be general. Still got to be considerate. Okay. How many? Do you guys remember the formula to determine how many degrees are inside this total?
360.
Well, you know it's 360, but how'd you do that? What was the formula? Something to do with n.
N take away 2 times 180.
And what did n represent?
N represents the amount of angles. Or
The amount. Oh, that's a good way of looking at it. The amount of angles. There's 4 angles, or the amount of sides. That's nice. I never even thought about that. That's so true. This represents the number of angles or sides. There's literally 4 different angles here. So, David, mind blown. You could just say that too. The amount of angles. Whatever makes sense to you guys. So, how many angles are there? 4 minus 2 times 180. That gives us 2 times 180, all right? And that's how many degrees? 360, as Zane was saying. So in here, they have to total up to 360. How do you solve for x then, in this case? Well, I'll help. Go ahead. Did you have something, David?
no.
All right, so they all have to add up to 180, right? So what is that going to look like as an equation? What equals a 360?
You could just add up all the sides to equal 360.
Or you mean all the angles, right?
Angles.
Yeah, 80 plus 80 plus,
X.
2x.
ooh, plus another x, which will simplify down to what Zane was just saying. If you have one x and another x, then how many x's total do you have?
7.
And then 80 plus 80, if you want to combine that, that'd be like 160. If you don't know why, think about the zeros just being, they'll just add up to 0, and then the 8s come up as a 16. 360, okay? There's a point to this, guys, trust me, right? To solve for x, I subtract 160 from both sides. 2x is equal to, what is that?
200.
If I divide both these guys by 2 to get x, that's x. What is the measure of this angle right here? What is the measure of this angle over here? These are opposite angles. What is a consecutive angle? 80 and 80 are opposite. What does consecutive mean? Yeah, David?
They're on the same line.
They're on the same line. So here's a line, and there are 2 consecutive angles, 80 and 100. What do they add up to? These are consecutive angles adding up to 180. That's supplementary, right? How about these two? What do they add up to? And how about these two? And how about these two? No matter how you spin it, as long as it's consecutive, 1, like 2. I like what David said. David, you're nailing down these definitions in an easier way to understand. I like that. If they're on the same line, that's way easier to understand, right? 2 angles on the same line should add up to 180. That's exactly what this says. If you have consecutive angles, guess what? They're supplementary. I guarantee you if I change this to 70 and 70, these pairs would still add up to 180 if you set up your equation like this, okay? So just remember that, right? Angles on the same line in a parallelogram add up to 180, right? And then how about this one? Same law. It's the same thing, but it's a special law. If I had one 90-degree angle, I could figure out all the other angles. What would they all be then? How'd you know that?
Well, you probably have to put the sides are the same.
Okay, so let's see. Wait, what?
Wait, no, you wouldn't actually.
No, you're right. No, you wouldn't. Yeah, you're right.
Yeah,
You're smart.
right.
So hold on.
There were 5 sides.
So if I knew this was 90, what else do I know is 90?
One under.
Which one?
Right under the angle right under.
This one right here or this one?
No.
This one?
Yeah.
How did you know that?
That adds up to 180.
Yeah, this adds up to 180 because that's 90. That's got to be 90, right? What about if I didn't know that was 90? Would I know this one? What would that be? because they're opposite angles. And if it's a parallelogram, which I didn't mention, they are, then I know these opposites are 90. And if I know, how about this one? What do they have to add up to?
90.
What?
180.
180, and then this has to be 90. So this is a very special parallelogram. It has a name. Does anybody recognize this name of this parallelogram? Yeah?
Rectangle.
This is a rectangle. So if you think about a rectangle, it is a special parallelogram, right? Where the degrees are all 90 degrees. That's all. That's the only difference between this and a rectangle, okay? Well, then we start doing the diagonal stuff. All right, so we learn more about this stuff. We're going to use all these things to our advantage in a second, right? These are just things to kind of learn about here. But let's take a look at this one here. All right. So, Zane, nice call. If I drew a diagonal between my parallelogram, I would get two congruent triangles. Not bad. That was pretty smart. What about this one? What is this saying? If I had two diagonals, then what's going to happen? You can literally read the definition. Just tell me. They have to intersect. So what does that mean, though? Like, how does AP and PC compare?
They're the same.
AP is going to be the same as PC. Why? Because these diagonals bisect each other, meaning they hit the midpoint between this line and this line. 1, 2, 3, 4. 1, 2, 3, 4. Does that make sense? Okay. So remember that. When these diagonals hit, they create two congruent segments on this diagonal and this diagonal. However, is BP congruent to AP? They are not. BP is only congruent to the other half of its line, PD. Does that make sense? Okay. You guys want to take a picture of that? It's in the book. I like that. But the other pictures, though, we might need for today, okay? So let's work on some problems now, knowing these things that we know now, right? Now we got enough skills to kind of work with. So let's check this out. Bam. Zoom out a little bit. So if you're doing this at home, guys, you guys can actually slow down and actually take formal notes now. But in class, it's just going to be a little bit more interactive, okay? So it gets stuck in your brain. But now if you need a reminder, you got a video or you can take some notes, all right? So let's draw, okay? So let's say we're on 8-2. You can take this down as notes right now even. Parallelograms, okay? And I'm going to draw, let's see. We're going to start using some properties of parallelograms. I'm going to shorten it by putting two parallel lines in ogram. I'm going to shorthand it by saying parallelograms. Okay, get it? Parallel lines in ograms. Using properties of parallelograms is the subtopic. And then now we're going to use an example in which we use the properties, all right? So here's one parallelogram I'm going to draw. I'm going to name this parallelogram A, B, C, D in this way. And then I'm going to tell you right now in writing that the measure of angle A is equal to 55 degrees. And then after that, I'm going to tell you that AB is going to be equal to 2.5 feet. And BC is going to be equal to 1 foot. Those are the only things I'm going to give you. But I'm going to ask you to find the measure of, I'm going to put ... and then here's part A. Can you find the measure of DC?
If they're congruent angles or sides, or just have.
Sorry, this is confirmed that this is a parallelogram. Boom, boom, and then as David was putting two arrows here and here. That's all you know.
5 feet?
What's up, DC?
No, 2.5 feet for AB.
Yep, 2.5 feet here. And BC is 1 foot. And then the corner here is 55 degrees, okay? So what do you guys say? Anybody here got something for DC? What is DC going to be equal to?
2.5 feet.
Why is that?
Because since it's a parallelogram, opposite sides have to be equal, right?
Very, very good. Yep. Because DC is going to be equal to AB. If you must know, I'll put a comma there and just say DC is equal to AB. So you can explain it to yourself that you understand why. Okay, how about this? What if I said find the measure of angle B? A little bit tougher. What do you guys think for the measure of angle B? Yeah.
Would be 125.
You are absolutely correct. It is 125 degrees. But why?
180 minus 55.
Well, how'd you know it was 180 minus 55?
Because they're supplementary.
Which ones are? Which angles?
A and B.
A and B are supplementary. So that means the measure of angle A plus the measure of angle B is equal to 180 degrees. We know that because consecutive angles on the same line, as David was saying, add up to 180. They're supplementary. We don't know the measure of angle B yet, but we do know that A is 55 degrees. We don't know the measure of angle B. That's unknown, 180. And then what Zane was saying is you're going to end up subtracting 55 degrees, or 55 from 180, and then you're going to get the measure of angle B is 125 degrees. Very, very good. Last one. It's going to be a trick. No, I'm just kidding. There's no trick. How about just the measure of angle C? You can look at your phone if you need for your properties too. You can keep that open at all times. Okay, Zane, what do you say?
55.
Yeah. Someone else, can we figure out why that is 55 degrees for the parallelogram, or for this parallelogram? Yeah, David?
Is opposite angles
Yep.
equal on a parallelogram.
And which one is going to be the same as measure of angle C? Yeah, measure of angle C is equal to the measure of angle A. And the measure of angle A is 55 degrees. So if I substitute in 55 degrees for the measure of angle A, measure of angle C is equal to 55 degrees as well. Okay. Let's see if I can find out another one. All right. Let me see where we're at right now. All right, we're going to do example number 2 and 3. So you guys ready to do this to the next level now? All right. Okay, so still the same subtopic. Different example now. It's going to be a little bit more complicated. Another parallelogram. We'll name this QR. This is a parallelogram, by the way. ST. Now let's look at the diagonals. And let's start including some more difficult values. So this is an example. QRST is a parallelogram. It needs to be said that they're a parallelogram, right? Now let me put in some values. All the angles are going to be in green, okay? So 95 degrees for this angle here. This one here. This will be 33 degrees in the corner. In the corner down here, it's going to be 3Z degrees. 3Z. And let's see, for anything that's a line, I'm going to write in orange. RS is going to be 27. QT is 5x. Q to T. Sorry, in the middle is P, all right? The middle is P, point P. PR is Y plus 4. And then PT is going to be 2Y minus 5. Here's going to be my questions for you guys. You guys need to find the following variables. So this is going to be all board work right now, all right? So try to figure out the math. I want you to find x, I want you to find y, and then I want you to find z, knowing what you know right now. How would you set up these equations? Help each other out, okay? So Luke, guys, get up here now. Now please work on the...
What are those angles in green? What is it?
Let me zoom in a little bit. The top one is 33 degrees. The one right below is 95 degrees. This one over here is 3z. So I would say the hardest one's going to be z to try to set up, but everything else you guys can set up. Good luck. So Luke, come on up here and then work with each other here. So just try to think back to some of the properties we know. What's up?
X, Y, and what?
X, Y, and Z. I want you to find all three letters in this one. It's a little tricky. I say this is a tough one to set up. All right. Let me see what you got here. So for the first one, for X, think about how you'd set that up. So 5x is QT, right? What do we know about QT?
Equal RX.
All right, so if 5x and 27 are equal to each other, how would you set that up as an equation to solve for it? Yeah, there you go. All right, so go ahead and don't worry about the letters right now, okay? In fact, let's just take a look. QT is equal to who? Which side is QT equal to? All right, so 5x is equal to 27, right? Why don't you just write that down right now and solve for x? 5x is equal to who? 27. Can you solve for x now? That's awesome. That's awesome. You can grab a calculator for this if you know. X is equal to there you go. You can use that one. 27 that one.
It goes into it 5 times.
Yeah, it does. And then you're gonna get left 2 left over. There you are. Okay, what about the diagonals? The diagonals cross each other. They bisect each other, right?
Did they bisect each other?
They do. Check your...
Oh, wait, no. I was thinking all four lines bisect. Yeah, that makes sense. I got you.
They bisect each other. So that means, let's look at this diagonal, T to R. What does that tell you about TP and PR?
They're the same.
They should be equal to each other. They got cut in half perfectly. So what that means is diagonals here cut each other in half perfectly. So if they cut each other in half, that means that TR is going to be equal to PR. How would you set that up to find out Y? That is correct. You set up 2y is equal to y equals 4. So think about it this way here. You see T to P is 2y is equal to 5 minus 5, right? P.
So we have a quick question. So
Yeah.
Is that 95 degrees and 33 degrees or 30 degrees?
33.
Shoot, hold on. Wait. I might have copied that wrong, boys. No, that is 33 degrees. Yep, that is 33. I did not copy that incorrectly. It's 95 and 33. Staying easy. The last one's probably the toughest one.
You said once you realize it, but it's a trick question. It's like you don't realize it immediately.
Is that for 2 with y? Is that a plus?
2 minus 5. 2y minus 5 is equal to nice. How did you know that? They're not vertical. Vertical means they're right across from each other.
I mean,
Something tells you that they are, right? Well, you have to first know, are these lines parallel?
Yeah.
And if you have a transversal between two parallel lines, what kind of angles are these? If they're on the in between the two parallel lines, on the inside, and they're not on the same side, they're alternating. What do we call that? Alternating interior angles. So Luke, check this out. This is a refresher way back, okay? These two angles here seem like they're already in the room, because they are. You set up as 3z is equal to 33, and you solve for z by dividing both sides by 3. The reason why is because, do you remember, if you have two parallel lines, and you cut a line in between them, you create what's called AIA. Do you recall what that is?
No, I never learned this.
All right, well, you get to learn it now, okay? If you cut, basically, if you got two parallel lines, you cut a line in between them, the opposite angles on the inside. You see the insides here?
Mm-hmm.
Lines like on the inside of the parallel lines. Alternating interior, they're called alternating interior angles. All you need to know is that those lines are going to be parallel or equal to each other, okay? What about 95? Who's he going to be equal to? Is he going to be equal to 3z? No, because they're not alternating. So who is he going to be equal to though? If I call this angle 1, let's just label it angle A, this is angle B, this is angle C, and this is angle D. Who is B going to be equal to D? Okay? So just so you can just see visually where it is, it's going to be equal to angle D. Okay? All right. Very good. Let me drop the solutions for the notes. So go ahead and have a seat, guys. Relax for a second. So I just have to write this as a review. It's going to go into the video. How you solve for x is that you know by the lines here and here, opposite lines, parallel lines are congruent. So that means that QT is going to be equal to RS, meaning that's 5x is equal to 27. 5x and 27. You divide both sides by 5. X is equal to 5.4 if you plug that into a calculator. Okay. B is diagonals cross each other and bisect each other. They cut each other in half, meaning this half and this half of TR. So TP is going to be equal to PR. So if you guys want to write this down in your notes to follow along with me, you may as well. TP is going to be equal to PR. So that means TY minus 5, which is equal to TP, is going to be equal to Y plus 4. You add 5 to both sides. You get 2y is equal to y plus 9. And I saw in Obide's work, you subtract y from both sides, and you get y is equal to 9. Not bad. The final one is a tricky one, C. You have to notice that, so Obide, you notice that 3z and 33 look about the same, because they are. 33 degrees is equal to 3z degrees. Then you divide both sides by 33 or by 3, I'm sorry, which you get 11 for z. But do we ever judge things on just the way they look in math? You can't do that.
I knew it was a rule. I just didn't remember.
You knew it was a rule though, right? Something about you said that these two, not just by looks, was equal to each other, but something that you knew inherently felt like these were. And I'm going to review this right now. Like we were just talking on the board, but this is for the video. These two lines are technically parallel. And if there's a line in between the two parallel lines connecting each other, if you remember in the past, within the two parallel lines, these are alternating angles. We call these AIA. That is short for alternating interior angles. These two are alternating angles, and they're on the interior, on the inside of these two parallel lines. That makes these congruent, okay? So I think you guys already know that. And there you guys are. So those are the answers there. I have one more question for you guys for this section before we go on to 9.2. And so, fair warning, there's a proof here. Write this as a note to yourself. In this section, 8.2, if there's any proofs, I don't want you to do them. I don't want you to do any proofs this month, okay? This month, let's just focus on the algebra and not so much the geometry, which is proofs. Geometry is, well, proofs. So no proofs. However, for this section, I do want you to at least try coordinate stuff, okay? Ignore proofs, try coordinate stuff. Let's take a look at this to save some writing. You may copy this down in your writing here. It is in your book. And I think it's important that you have it somewhere so you remember how to do these problems. Let's look at what that says. Huh?
Isn't there a shape?
What shape? No, there's...
Right there, you see it, it's just next to the G8.
Oh, and he was asking, though, is there a nice drawn-out shape in this problem? No, they're all words and text. That means, though, we can do it, though. We can draw the shape. Not a fun idea, but we can, right? Determine the coordinates of the intersection of the diagonals. What? What does any of this mean? First off, what are we going to have to do if they give us these points? What do you think? We can plot them. We can. We don't have to, but we can plot them. This is going to go into what we kind of talked about earlier. So let me grab... So the solution's right there. You can try to interpret what the solution is. I don't think it's very easy to understand. That's why I'm here. That's why I think I'm here. Is to try to help you to understand this stuff. First, let's plot this. Let's draw. So if you need to write notes, say page, I don't know, put page 488, example 3, okay? If you want to put a note down, you can say to yourself, this is page 488, example 3, and 9-1, just so you know that this is what we're doing the answer for, okay? 8-2. I'm so sorry. Yeah, you must have been freaking out. Like, what? This is how Mr. Wee graphs. As long as he does equal spaces, increments, like 1, 2, 3, 4, 5, 6, 1, 2. It doesn't matter how many. Just do like maybe 4 or 5 on each side of the y and x-axis. Then you're good. You don't even have to use graph paper. You got that, okay? Then, as long as they're equally spaced, you should have a nice, good, shape. At -2, 4. So at -2, and you go up 4. 1, 2, 3, 4. Around here, you're going to get F. I like to kind of write in the numbers 2, -4, or -2, 4, just so I know. I don't have to keep looking back and forth on the question here. Then let's plot G, which is 3, 5. So I'm going to move over to the right 3, 1, 2, 3, and then I'm going to go up 5, 1, 2, 3, 4, 5. Like it's right around here. So that's G. That's 3, 5, guys. You guys don't have to wait on me. You guys can graph the rest if you guys would like. I'm just going to go slow. At H, that's 2, -3. So that means I'm going to go to the right 2 times. 1, 2, and then go down 3 times. 1, 2, 3, down negatively. That's G for... Or H, I'm sorry, guys. I'm getting a little tired there. My bad. 2, -3. The last one is -3, 4. So that means I go to the left 3. 1, 2, 3 to -3, and I go down 4. 1, 2, 3, 4. That's your shape. Let me ask you a question. Does that look like a parallelogram?
Did you write 3, 8, or is that
5, sorry. Good question. That's a 3, 5. Does that look like a parallelogram so far? Kind of does, huh? Right? Yeah, I like David's expression. That's perfect. Just like, yeah, I don't know. Kind of, yeah. Yeah, we don't know. So they kind of tell you what to do, though. What are they telling us to do? Well, I know it says determine the coordinates, but what are they asking about this? What does that say? So what does that think? What do we think we're going to draw in here? From F to H, and then G to J. We got to find the coordinates for this bad boy. What do we know about parallelograms and diagonals? What do we say about the diagonals of parallelogram?
They bisect each other.
Another word is intersect, bisect. They cut each other in half, right? If they bisect each other. So think about it this way. This point is what to this line? From J to G, what is this point? Well, let's name this point right here. What do we need? One letter. What do we want to name it? So why don't we say M for midpoint? Because we're betting it's the midpoint. I think I just lost my other pen somehow. Let's call this M. So that's M. So let's go back really quick to here. Remember, it says that the diagonals bisect each other, but that also means in here, in this example, P is the midpoint from D to B. What about P in terms of A to C? Is P also the midpoint from A to C? Yes or no? It is. So, can we find that M is the midpoint of J to G? Yeah. But what do you think we also have to do? That's just step one. Why?
So that way you know it's the middle.
Of not just one diagonal. And if we do that, what does that tell us about the shape? It is indeed a parallelogram. That's how you define it, right? What's another way we could do this in coordinate? Instead of finding the midpoint of these two diagonals. Is there another way we could have done this, by the way? Am I getting too far ahead of myself?
It looks like it's...
Well, you can't say it looks like it. You got to prove it. Anyways, let's just go back. So let's find the midpoint of J to G. How do we do the math for that?
You can't just look at where it is on the graph.
No, you can't. People do that, and if they actually coincidentally get the right answer, I'll give them credit. But I'm going to give you full credit if you can do the math to prove that. Not just by eye. Because, right, this is limited to how good I am as an artist. Math, though, never limits itself to how bad someone draws. Okay? Good math is just good math, right? No matter how bad you write it. That's the beauty in the math. Bad drawing, though, could lead you to the wrong answer. Yeah.
You would add both sides and then divide by 2.
Add both sides, or what?
Or not sides. The x's and the y's.
The x1, x2 divided by 2, like what we did in the beginning, and the y1, the y2 divided by 2 to get the midpoint. So let's check it out. JG, let's do that. The coordinate for J on the x is -3, and the G is 3 divided by 2. And then the y's are -4, and what else?
5.
Divided by 2. So let's check out what we end up getting. What is -3 plus 3?
0.
So 0 divided by anything is... Let me tell you one thing, trivia. 0 divided by 0, though, is not a real number, by the way.
Yeah, because nothing divided by 0. Wouldn't it be 1, kind of?
It looks like it'd be 1, but it's what we call a calculus indeterminate. And you're gonna...
Nothing can divide by 0.
Yeah, like you can't have nothing divided into 0, right? I don't know, it's just weird. The concept's odd. How about -4 plus 5? What is that? Yeah, it's about 1. So 1 divided by 2 is... So look, that looks kind of like it, right? So Obai, that's the bad thing about my drawing, right? Look how fat my pen is. That doesn't look exactly like 0, 1/2. So that would have gone you, based on how I drew it, might have gotten you some points off the exam, right? But with good math, you can totally verify that this is good. So this is supposedly the coordinates for M. But remember, we don't want to do it just for one diagonal. We got to do it for the other, or not just this diagonal, but this diagonal. The whole point is also if your midpoint between J to G is the same as F to H, that means you got a perfect bisection right here, right? Or intersection, I'm sorry, okay? So let's do that. I'm going to do this in a different colored pen. The M point, the midpoint of F to H. Why don't you guys work on that on your own right now at your desk, okay? So again, if you had to remember, the formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So I'm going to freeze frame this right now. And I'm going to let you guys work on this on your own. And then I'm going to do the math on my own, right? All right. Did you guys get 0, comma, negative, or 0, 1/2? 0, not negative, but 0, 1/2. All right. If you want to see the work, it's negative 2 plus 2 divided by 2. Negative 3 plus 4 divided by 2. And then you guys should get on 0 divided by 2 again, 1/2. And then this is the same thing as what we got before, meaning that line or that point is the same kind of intersection or bisecting point on both diagonals. So is this a parallelogram? Yes or no? This is by far a yes for this is a parallelogram. Okay. Awesome job. Again, please do not do any proofs in this chapter. So if anything was assigned that's a proof, don't do it. We're going to move on to the last one, which is 8-3. It's the same set here. They have some more definitions. The only thing new, guys, is this last one. What does the last thing say? Try to figure out what that thing is saying. What is that last bit there? This is the only new part, the only new theorem that we really want to know about from this 9-3. 8-3. Thanks, so much. Yeah, David, what do you think this says?
It means that if one pair of opposite sides are congruent and parallel, then the shape is a parallelogram.
All right. So if these two are both parallel and congruent, do I need to know anything about AD and BC at all, technically, to find out if this is a parallelogram? No. This is a shortcut. As long as you could say just one pair of sides is both parallel and congruent, this is a parallelogram. You need to check no further. Okay? Draw that right now. Go on the whiteboard and draw it right now. Draw me a parallelogram with only one pair of sides that's both congruent and parallel. And then tell me that's not a parallelogram. So right now, draw me a parallelogram right now with only one pair of sides that's parallel and congruent. Just one pair. Remember, the lines have to be the same length as well. That's the key. So that's the challenge right now. I'm going to try to trick myself. I'm going to be like, I don't believe that. I'm going to say, these lines are, look at that, way off. They're parallel and they're congruent. After you're finished, though, connect the other lines and tell me these lines are not parallel as well.
Can we curve the line?
Huh?
Can we curve the line?
No, you can't. You can never. It's not even a line no more. Come on. Yeah. Do you not know the difference between a curve and a line? No, I'm just kidding. Yes, you're right though. Or you. That was a good question. No, you cannot curve the line. Now connect the vertices now. Not diagonals. No diagonals. Just the vertices. And then tell me you did not create a perfect parallelogram. That corner to the bottom. Yeah, just go slow. No matter how you try to spin it, as long as you drew it nice and fair, you're going to create a parallelogram. So which lines did you choose to be parallel? These two? And then they're the same length? How about these two now, the results? Are they the same thing? Parallel? Are they parallel?
This one.
It does. All right, well, let me draw one that looks pretty good. Actually, it looks parallel. Do they look parallel? Yeah, it's a bit shorter. So, all right, so let me get a ruler, right? Try to be perfect with this. Because I want your brain to sink it in. I don't want your brain to think something wrong. So let's do this as 4 inches, right? And let's do a line that's about the same. So I went down here. It's a little slanted, right? 4 inches. That was a little about parallel, right? Let's connect these now. Let's see if they're the same length and they're the same slope. Are those the same slope, would you say? No, what do you think? Do they look like they're similar the same way? Yeah. How long is it? About 4 inches. How about this one? So that's the same. So you just created a parallelogram only knowing that this and this are parallel. These are congruent. That's all you need. As long as those two lines are a pair. Even these ones. If you drew 2 lines, a pair, that are both equal in length and parallel, this one will be the same way. The same length and they're both parallel. Okay. All right, let's have a seat, guys. Now let's use this to our advantage. Here's your first example, buddies, people. Tell me right now, guided practice right here. This problem right here. These 2 quadrilaterals. Why did I not call them parallelograms? Yeah, they're only 4 sides, so it's a quadrilateral, but we don't know if they're parallelograms. So let's have a look. Are they parallelograms by definition? Check your phone or check your properties that you have and include the last one that we just learned about.
Yes. Probably.
Don't give me a probably, give me a definite answer. Yes or no? What do you think?
Yes.
Okay, how do you know the first one is a parallelogram? Because you said so. That's not going to work. Not in my book, all right? Not in this book that we all have. Okay, what'd you say?
Because of all opposite sides are equal.
Equal.
They're congruent.
Okay, they're congruent. So this is by far. What about this one?
Just with the 2 sides, you already know it's congruent because they're both 85.
Well, yeah. Oh, okay. I see what you're saying. Oh, yeah. Like, yeah, I guess you can kind of say that. Yeah. But let's see, 85 and 85. So what does that say about the angles? What are they in relation to each other? Actually, why are you guys hesitating? Tell me why. They're just opposites, but is that enough to tell you that this is a parallelogram?
Yeah.
Oh, it is? It does.
It also says that there's 2 congruent lines.
Yeah, but is there any property?
That the other 2 angles equal 95, right? Make it a parallelogram.
Yeah, that's true. Yeah. You want to see what your book says?
Yeah.
They say 1A is yes, but they say none of the tests are fulfilled. The reason why, hold on, let me go back. I'll say the book's wrong, okay? You know why? They're just saying, they're trying to trick you and saying, just because we gave you a pair of opposite angles are the same and a pair of lines are the same, they wanted to say, oh, most students think that is 8.12. that they're trying to use 8.12 to explain this. But the truth is, yeah, I would say, yeah, it's not this condition, but you just said it yourself. 85 and 85 are opposite angles, right? And they're congruent. So that tells us that as long as these are straight lines, that this is going to be adding up to 180. So that makes this angle how much, did you say? And then if this was 95, this is... Oh, but here's the thing. Let me see. I don't know. I guess they're trying to say that we don't know if these lines are actually parallel. They could possibly be like, maybe like, I don't know. Yeah. Maybe that's it. I don't know. Maybe that these are supposed to be different lines. I think this is too tricky. That's kind of unfair, huh? That's a lot unfair. I didn't like that. All right. Forget that one. Yeah. I would say yes, but we don't know for sure, right? I don't know. Because I think they're just trying to trick you, but they did a bad job in trying to trick us. Okay? All right. Where are we at right now? How far did I want to get? How many examples? So I got about 2 more examples. 10 minutes. Okay, let me give you some info right here. Okay? This one, we are not going to do anything like this. Okay? So anything like example 5, do not do. Okay? These are with general terms. I think that's a little bit too far, right? So again, write this down. Any problems, or just take a mental note, Luke. Any problems that look like this, example 5, don't do them, okay? Example 4, go home and study this. In my other video, we do go over this example with the honors class, okay? But I'm not going to have a problem like this on the exam, okay? But do the problems, though. I'm still going to want you to try this at home. These are with numbers, but I'm not going to have anything like this on the exam for this section, okay? So really, the most important last piece that we're going to go over is probably one of the pieces more likely to occur on the exam.
8.3.
This is 8.3. Yes, sir. This is 8.3. All right, here we are. This is confirmed to be a parallelogram. I will say right now this is a parallelogram, and here are the sides, meaning that I'm giving you this information. Even despite the way I might draw this imperfectly, this is a parallelogram. Your choice now. Yeah.
This is for 8.3.
This is for 8.3. Example 3 for 8.3. The middle point is K. Here is the given information. F to K is 3x minus 1. K to H is 2x plus 3. K to G is 4y plus 3. And JK is equal to 6y minus 2. Let's see. So they're going to ask you the question like this. Find x and y. Find x and y so that this quadrilateral is a parallelogram. So you have to solve x and y in such a way that this is a parallelogram. What the heck does that mean? What does that mean? What does that mean we're going to have to do? Find out x and y so that the quadrilateral is a parallelogram.
The opposite lines have to be equal.
What do you mean opposite lines? You have
Like,
some.
would we have to find each angle measure? Or...
Do we have to find each angle measure?
Yeah, there are any numbers.
Yeah.
There's not any numbers for the angles.
So like JK and KG,
What about them?
you have to set them equal to each other
Why?
because in
Sorry to challenge you like this. Huh?
all the opposites or all the diagonal lines are equal to each other because it's bisected.
Because these two diagonals are bisecting, right?
Yeah.
They intersect at this line and they bisect, meaning this line is cut into how many equal parts, guys? J to G is cut into how many equal parts? 2 equal parts. Boom and boom. So what does that mean we're going to have to do? We could say that what? JK is what? Equal to what?
KG.
Uh-huh. And then how about the other guy? I'm gonna do one, you do one. I'm gonna solve for JK. You guys are gonna solve for FK and KH, right? Or you guys are gonna solve for the other variable. So JK is 6y minus 2 is equal to 4y plus 3. So I'm gonna solve for y because I know that JK is equal to KG, and then they actually both parts have the same letter or variable, y's. So if I set them equal to each other, I can actually solve for y. So what I did was I set 6y minus 2 is equal to 4y plus 3. Then I solve for y by adding... Oh, did I do something wrong, guys?
Yeah, I think it's supposed to be 5, not 6.
Oh, up here. I added 3. I should have added 2, huh? I messed up, guys. That's why you guys were talking, huh? My bad. Like in terms of like what I was doing wrong. This is plus 5. So this should have been 5. 2y is equal to 5. 5 divided by 2. What's 5 divided by 2?
1.6
What?
It's divided by 3.
Could you keep it as 5/2, or do you have to bring it down to decimal?
Hey, you could leave it as 5/2. Good point. Or you could just put it as a decimal, which is 2.5. There we are, Obide. I like that. What about FK equals KH? What am I going to have to do there, guys? Same thing, which is what? What would I have to set up? What is FK equal to?
3x minus 1 equals 2x plus 3.
Okay, then I solve for x. I'll add 1 to both sides. So that'd be like 3x is equal to 2x plus 4. I'll subtract 2x from both sides. X is going to be equal to. All right. Want to try one more? All right. So we'll leave there. Okay, so go home. Try to figure out what they did here. Okay, they found a bunch of slopes. Actually, you guys want me just to describe what happened here really quick? When you go home, you can go home and try to study over this. They have to prove that this is a parallelogram. And here's the rule that they want you have to justify that this is a parallelogram by using the slope formula. So what you have to do is, if you remember, I asked Obide earlier, if they're parallel, like KN and LM are parallel, that means that their what is the same. Their slope. So that means you have to find, they give you the coordinates, you have to find the slope between K and N and L and M. And they did that. Or KN. And they found it to be 6. You have to make sure that this slope and this slope are equal to each other. So the slope of Kn is equal to the slope of Lm. They calculated that to be 6 and 6. That means that these two sides are parallel. Then they had to do it for KL and NM. Okay? And then they got 1/6 and 1/6. And then that ensures that that's a parallelogram.
Isn't it also a square if all the sides are 6?
No, because a square is like a specific rectangle. Because the degrees have to be 90 degrees. So just because you have 4 sides with the same slopes does not mean that they have 90 degrees.
The same side.
Okay.
Put it on the paper or whiteboard?
Whiteboard, really quick. Don't even draw it on the whiteboard. Just try doing it here. Solve for x and y on these bad boys. And then you guys can go home. And you guys are free. Nice. Just got yep. All right, guys. Check your answers here. I'm gonna leave this up. You guys are free to leave.
Thank you, Mr. Lee.
All right, no problem. All right, you guys are good to go now. You guys are all good. So, guys, just go ahead. Yeah, you're all good to go. You guys have a good day.
Have a good weekend.
Yeah, thank you very much.